Okay, and then in the middle, we're going to have a chlorine molecule with one chlorine 35 and another one with a chlorine 37. So there are two probability. Okay, we could either remove electron from chlorine 35. Okay, so chlorine 37 stay as the atom, but we remove an electron from chlorine 35. That's one possibility. And we could have another possibility that we have removed electron from chlorine 37 and form the ion. Okay, so if we focus on one of them, focus on this one. Okay, the probability of having chlorine 37 is 1/4. The probability of having chlorine 35 at the second atom gonna be 3/4. Alright, so that's gonna be the same for this one. So we got two of this. So two sets of this. So we need to multiply by 2. Okay, so overall this will give you 6/16. Okay, that's 9/16, and that's 1/16. So you see the ratio for these 3 ion. Okay, these 3 ion should be 9 to 6 to 1. Okay, so by reading the relative abundance ratio of the molecule, you could also work out the ratio for the two isotopes. Okay, so that's another use of the mass spec. Okay, 9 to 6 to 1 ratio. All right, so that can be applied to bromine, which is a bit easier to understand. If you don't understand this part, that's okay. Let's try to apply this on bromine. Okay, so for bromine, it got two natural occurred isotopes, bromine 39, bromine 81. Okay, almost 1-to-1 ratio. Right, so it's equal chance to having bromine molecule made of 2 Br79 and having 2 atoms of Br81. Okay, same probability. And then for Br39 with Br81, okay, so it's gonna because it can have 2 combinations, that'll give you this ion. So it's gonna be double the abundance compared to this 2. So the ratio you could read from this mass spec is 1 to 2 to 1. Okay, because it's 1-to-1 ratio, so equal chance of having 2 Br79, 2 Br81, or Br39 and Br81, or Br81, Br39. Okay, but these two, they're going to show a peak at the same m/z. That's why this one is double the height of these two peak. Okay, so that's another use of the mass spec. It show you the abundance of, show you the ratio of the molecules with different combination of the isotopes. Okay, and we could also use this method for more complicated molecules, and it can help us to determine the structure of the molecules as well. Okay, so that's another use of the mass spec, but we're not going to talk about that in our syllabus. If you have interest, you could go search online. Okay, so that's for the mass spec here. Sorry, what?
Can you repeat your sentence?
So the mass spec can also help you to determine the structure. For example, whether you have a branched organic molecule or a straight linear molecule. Okay, so that can be worked out by the mass spec. So if you are interested, you could search online. There are loads of videos talked about that, but we're not going to cover that in our syllabus. Okay, so that's all for the mass spec. And then don't worry, the question you're gonna see would not be so complicated like this. Okay, so let's see some example together. So here, a mass spec for element A is given to you. Could you work out the answer for these questions? Give you a few minutes to take a look at the question and write down your answer. And when you finish, can you let me know? Type an OK in the chat box. Okay, so maybe we begin with the first one. Right, so you can unmute yourself and read out your answer. Okay, so first one, define the term isotope. This time we work backwards. Linus, what's the definition for isotope?
Different atoms of the same element with different number of neutrons but same number of protons.
Yep, very good. Okay, and then how many natural isotopes are there in element A? Marcus? Hi Marcus, how many natural isotopes are there in element A from the graph, from the given information? Come on. Okay, 4. Yes, good. Okay, so you could, you could type in the chat box so everyone can see that, right? Okay, we just answer the question according to the information given to us, okay? And then next one, given that the atomic number of element A is 84, how many proton, neutron, and electron are there in an atom? So who's next? Emily, please.
Number of protons 係 84.
Yeah, very good.
Number of neutrons 都係 84.
Yep.
The number of electrons 係 124.
Okay, so sorry, number of electron is
124.
okay. So here again, you need to pay attention to this. So number of protons should be the same with the number of electron. Okay, so it would be both of them should be 84. So we're talking about atom here. It's no ion.
我搞錯咗。
Yeah. So it should be the other way around. So the number of neutron, yes, you need to do subtraction. So and the answer you gave to me, 124. Yeah, very good. And then calculate the AR of element A. What's next? Larissa, please.
20.722.
20.7. Sorry, what? 22?
I think so. I'm not sure.
Okay, could you read out your equation? It's very close. I think you just put the wrong number in. Alright, so you can see the number we read here, 204, 206, 207, 208. Okay, so your AR should be somewhere in between. So it should be a number between, at least between 204 and 208. Right, so you can use that to check your answer because we are taking average of all of them. So it must be a number between this. Yeah, okay, so the correct answer should be 207.22. Right, so the equation would be you multiply the atomic number with the abundance, okay, and then you force them together. Sorry. And then it will be over now it will give you 207.22. Okay, and that's for the first question. Now we move on to the next one. This mass spec is a mass spec for neon. Determine the AR of neon. Okay, so you could refer to the equation we just had and then set the equation. Okay, so Rachel, can you let us know when you finish calculating this one?
40.2.
Well, the number doesn't seem right to me again. Okay, if you take a look at the mass over charge ratio, it's 20 to 22. Okay, so you expect your answer should be somewhere between, okay, like between, I would say 20 and to 21, because 20 isotope is more abundant. Okay, so okay, I'll show you the equation we just used here. And then maybe you could modify your equation accordingly. Okay, how about others? Okay, so here, remember, in this equation, okay, because the relative abundance here is not add up to 100%, so we're going to actually add them up and divide by the sum of those relative abundance. That's important in your equation. Okay, so you need to have that in the second question as well when you set your equation. Okay, that's because they don't add up to 100%. Okay, yep, I've received the first correct answer. Yeah, it should be 20 something. Okay, so you should have a feeling of where the correct answer should lies, like within. Okay, so
我想問下咧，係咪 correct to three significant figure 啊？定係點啊？
the question will let you know. But usually one or two DP, that will be okay. So for this one, so first of all, the mass times its abundance. Okay, and then divided by the sum of all the relative abundance. Okay, so you will get the correct answer 20.18. Okay, so remember, if the relative abundance is not equal to 100%, then you need to divide it by the sum of all the relative abundance here. Okay, so the correct answer for this one is 20.18. So that's for question 2. And then we move on to the last question for this unit, for this topic. Okay, so here, the mass spectrum of lead is given below, given that the relative atomic mass of lead is 207.2. Okay, so first we calculate how many proton, neutron, and electrons are there. Who's next? Sumi, could you let us know the answer for part A?
Hello. The number of protons is 82.
82.
And then the number of neutrons is 204 minus 82.
Yep.
Which is 122.
Okay, and number of electrons is?
82.
82, good. Okay, and then the next one, calculate the relative abundance of the peak at M over Z of 208. Okay, so how do we set the equation? Okay, we back to Linus.
我 set 條 equation 嚟，我懶得撳機。嗰個叫207 207.2 is equal to 好亂，204乘1.5加23.6乘206加22.6乘207加你 set 咗 y 啦 ，for 問號 y 乘208除以成條式除以15加23.6加22.6加 y。
Okay, it should be 1.5, right? Not 15, right?
我唔知，如果係1.5都得嘅。係啊 1.5，sorry， 我講錯。
Yep. Okay, good. Your equation is correct. So, okay, let's try to put those in the number and work out the answer. Okay, so you need to rearrange it, open the bracket, and work out the answer. Okay, so from the graph, you expect your unknown should be higher than 23.6, right? So double check your answer whether it matches with some aspect. Okay, so you also solve the equation, get the answer. Alright, so I give you the answer, and then if you're having difficulty solving the equation, let me know, and I could give you some help after the lesson. Okay, and then we're gonna move on to topic B. Okay, if you don't have the notes printed out and you want to have the hard copy with you, please go and do it now, and let me know if I need to wait for any of you to print out your notes.
send 咗去邊度啊？
WhatsApp group.
哦。
係咪完㗎啦？
For topic A, yeah, and then we're gonna move on to topic B. Okay, so topic A exercise gonna be available later. I will let you know. Okay, but due in 2 weeks' time, so no need to rush through those questions. Okay, so next part we're gonna go move on to topic B. Okay, electronic structure of an atom and the properties of different atoms on the periodic table. Okay, so we're gonna look at an atom in detail and build upon what you have learned in grade 9. So in grade 9, you have learned that an atom got different electron shells, and then how you're gonna arrange those electrons into different electron shells. Okay, so this part we're gonna learn, okay, what makes the electron shell, okay, and then how should we allocate those electrons. Do you all have the notes? Can we start?
分緊，你俾我1分鐘。
Okay, sure. So you could check the syllabus when you have to understand 6 parts. Okay, so you need to know the electron orbital configuration up to element 36 according to the 3 rules I'm going to introduce to you. And then you're going to learn different representation for electronic arrangement configuration. Okay, and 2 definition. And later you're going to see that cartoon, okay, where you need to memorize those important definition. And then you need to be able to draw the shape of the orbitals and then relate their properties to the position they are placed in the periodic table. Okay, so while waiting, you can take a look at my my screen. So last year we've learned ionization energy when we talked in unit 35. Okay, ionization energy. It's the amount of energy required to remove an electron from an atom in gaseous state. Okay, so how scientists find out that there are electron shells around an atom? Okay, so we studied the successive ionization of an atom. So this diagram represents the successive ionization of a sodium atom. So what does it mean? This dots represent the energy required to remove 1 electron, the first electron from sodium. And this dot represents how much energy is needed to remove the second electron on sodium. And that's the 3rd electron removed, 4th, 5th, and then up to the last electron removed from sodium. Okay, so look at this graph. I want you to fill in 2 parts on this from this graph. What's a general trend you could read from this graph? And did you see any exceptionals or any highlights you want to describe on this graph? Okay, think about this 2 questions. Later, I'm gonna ask you to say your answer. Okay, so it's better that you have a periodic table with you or next to you, so it would be easier for you to understand what
我
I'm
哋
saying.
開始先啦。
Okay, give you some time to think about this question. What's a general trend and any highlights, any exceptionals that you could find on this diagram? Okay, Marcus, can you let me know what's a general trend you find on the diagram? Okay, others, how about what do you think the general trend? It's from the 3rd period. See if it, okay. That's a periodic table. So sodium, 3rd period, group 1. Okay, I'm asking the general trend on
This
this.
is correct, right? I'm revising.
Yeah, but
Right, bye.
Okay, but what's the general trend here?
Increase.
Increase.
Orbitals, deionization energies are closer or whatever. Or the same sub shell, I mean.
Okay, yep, okay, yep. So you've also mentioned something that we're going to discuss in the highlight parts. Right, so first, let's see the general trend. You can see the energy level increase. Okay, so what's the reason for that? Why it needs more energy to remove those electrons? What's a possible reason? Anyone? You could type in answer, you could unmute yourself to say your answer. Okay, because of what? Okay, so here, remember, electrons, they are
harder to remove.
Yeah, harder to remove. Very good. And then electrons, because they are negatively charged, they have attraction to the nucleus, which is positively charged. Okay, so here, if we find out that it needs more energy to overcome that attraction, that means those electrons are getting closer to the nucleus. Okay, so that's because the remaining electrons are closer to the nucleus, and they experience less shielding effect from other electrons, the nucleus. Okay, so that's why we have a general trend, general increasing trend. Okay, because electrons are getting closer to the nucleus, and they experience less shielding effects, and they have stronger attraction. Okay, so now the next thing we need to read from the diagram is the highlights. Okay, so what can you see from the diagram? Right. You could definitely see there are two jumps in the diagram. First one is between the first and second electron, and then it's between the 9th and 10th electron. So what caused the two jumps here? And here it just gradually change, gradually increase. Okay, so you could see, okay, the energy on this diagram, those dots can be put into 3 groups. Okay, so in the highlight part, you can write the electrons fall into 3 groups. Okay, so when we remove the first electron, because it's further away, okay, or it is the furthest away from the nucleus, so only small amount of energy is needed. Okay, so that's the first group. And then for the second group, for those 8 electrons in the middle, they are getting closer to the nucleus, okay, and they're gonna experience less shielding, okay, so they need a bit more energy to move them, okay, from the atom or from the ion. And the last group, these 2 electrons, they are the closest to the nucleus, Okay, so a large amount of energy is needed to remove them. Okay, so that's how you're gonna expand this. Okay, maybe I write the explanation for this too, because my explanation is a bit long, so you could write in your way, just to help you to understand this part.
What?
Okay, so you can see the first group, only one electrons in the first group. That's because this electron, okay, group 1, and then for these 8 electrons, they fall into another group, group 2, and then we're gonna have a blue color, a green color. That's group 3 we have. Okay, so electrons in group 1 has the lowest ionization energy. Okay, it's far away from the nucleus. Okay, so small amount of energy is needed. Okay, so that's for the first group. And then in the second group, we have 8 electrons. Okay, so for those 8 electrons, they're getting closer to the nucleus. Hence, we need more energy to remove them. Okay, so you could say these 8 electrons are closer to the nucleus. Okay, and stronger attraction, so need more energy. Okay, so you can write for the third group. Okay, so the last 2 electrons, they have the highest ionization energy because they are closest to the nucleus. Okay, so that matches with our understanding for sodium. Because sodium is from period 3, we expect it to have 3 electron shell. Okay, so one electron in the outermost electron shell, and then 8 electron in the second shell, and then the 2 electron in the inner shell. Okay, so that's the evidence for an atom to have different electron shell. And in IFY syllabus, they use another term to describe this. So they call those electron shell different energy level. Okay, so have you finished copying all of this, or no, I will let you know when you need to memorize the detail. But you may see questions that give you the diagram and ask you to. Yep, okay. Yes, very good. That's gonna be your last sentence for the highlights here. Okay, so conclusion, what we could draw from this diagram is that electrons in sodium are located in 3 different shells. Okay, our conclusion, this proved that electrons in sodium atom are located in 3 different shells. Okay, and different shells have different distance to the nucleus. Okay, that's why you see a clear difference between the 3 groups of electrons. Okay, because they have a clear difference in the distance to the nucleus. Okay, so here the definition, you need to remember the sentence I underlined here. So the electron shells are located around the nucleus are called energy level. Okay, so if they have different distance to the nucleus, then they are classified as different energy level. Okay, so if you're gonna study chemistry in university level, they're gonna introduce in detail how you so that different energy level gonna be calculated according to different numbers, quantum numbers. But at this stage, you just need to remember different levels, different energy levels got different distance to the nucleus. That's enough. Okay, so here are some questions. So these are questions from A level, will be similar to IFY. Okay, or similar compared to DSE to IFY. Okay, so we could have a go for those questions. All right, so the first one, the first 5 ionization energy of an element are 500 something, 1,000 something, 2,000 something, 10,000, 11,000 something, and 14 or 18,000 something. Okay, so in which group of the periodic table is X bond? Okay, what's your answer? We should. The next one gonna be Emily. Could you let us know your choice for the first MC? Yep, sure. Take your time. Read the question carefully. Okay, I also show the second question. So if you finish with the first one, you could attempt the second one. Okay, so what's your answer? Can you let me know? Okay. I've received 2 different answers from 2 different students. Okay, so let me guide you how you're gonna work out the answer. Okay, so first refer to this diagram. Okay, we can find the first jump between the first ionization energy and the second ionization energy. Okay, there is a first jump between these 2. So we know the first electrons are in different electron shell compared to the second electron. Okay, so we just need to remove 1 electron and then move on to the next electron shell. That's why it's in group 1. Okay, so if we use this to think about, think about this question. Where can we find the first jump in the data given? Okay, so you can see a clear difference between the first 2 number and the clear difference between these 2. But the difference is not big enough to describe as a jump. But you can clearly see the difference between the 3rd number and the 4th number, isn't it? It's jumped from 2,000 something to 12,000 something. A big difference in these 2. So we can say these 3 numbers, okay, we're removing the electron from the same electron shell. But from the 4th one, we're actually moving on to the next electron shell. Okay, so they are getting much closer to the nucleus. So require a lot of energy to remove that electron. Okay, so there is a big gap between these 2. Okay, so you know you have removed 3 electrons from the outermost electron shell. Okay, so there are 3 electrons in the outermost electron shell. So this element should be in group 3. Okay, so the correct answer should be C. Okay, here we go. Okay, let me try again. So this one, okay, according to the data, you could see 2 jumps in the data. There is a first big gap between the first ionization energy and the second. That's the first big gap. And then you can see another big gap between the 9th and the 10th one. Okay, the gap shows that we're moving to a different distance. Okay, so you know I've removed 1 electron from the outermost electron shell. And this from the second electron, I'm removing it from a closer electron shell in the middle. Right, that's why this element, which is sodium, that's from group 1. Okay, only 1 electron in the outermost shell. Right, so now take a look at this data. It might help you if you want to plot a diagram. Okay, so the first ionization energy 578, and the second maybe 1817, and the third one 2745. Okay, but the 4th one you can see here 11578. If you plot a diagram, it should be around here or even a bit higher, somewhat like this. Okay, and then the next one 14831, another one here. Okay, so you can see there is a big gap between these 2. Okay, between the 3rd one and the 4th one. Okay, so that means these 3 electrons, they are in the outermost shell. Okay, you can see an increasing trend because it's harder to remove the second electron because it's already positively charged. Okay, we've discussed that before, the train for ionization energy. Okay, but the difference is not big enough to say that they're not from the same electron shell. Okay, so here the big gap tells you there are 3 electrons in the outermost electron shell. The 4th one is already from the next electron shell. these electrons are much closer to the nucleus. They are not in the same electron shell. Okay, so it should be in group 3. Why is not 4? Why x equals 4? I don't get this. Okay. All right. Okay, so do you understand why would you see here? Okay, so quickly, similar principle, can you find out the answer for the next question? Okay, so this one, although it asks you to write the formula, but you need to first find out which group it belongs to, and then it will be easier for you to find out the formula. Okay, so find the group that it belongs to from the data given here. So, Larissa, do you have any idea which group this element belongs to? Okay, so again, we're gonna try to find the big gap between the ionization energy. Okay, for example, we could plot a diagram look like this and see where is a gap. Okay, we're working backwards. So the first ionization energy 600 something, and then 1,200 something, and then 2,000 something. And then the fourth one is 7,000, so be roughly at this part, and then 8,000. Okay, so on this diagram, the gap is between the third and the fourth. Yep, okay, so you spot out the gap. So the gap tells you these 3 electrons, they are in the same shell, right? And these 2 electrons, they are in the next electron shell. Okay, so there are 3 electrons in the outermost electron shell. Okay, so which group does it belong to? And what charge are you going to carry when it becomes iron, or when it form a compound with other elements? So what's the answer? Okay, so now, is everyone okay with this part? There are 3 electrons in the outermost electron shell. Yep. Okay, so there are 3 electrons in the outermost electron shell. That means it's from group 3. Okay, so group 3, when they become iron, group 3, for example, aluminium. Okay, so if we have aluminium, okay, if element X is aluminium, so when it becomes iron, it should be X3 plus. Right? Okay, so now when we have a compound formed between X3 plus and O2 minus, what's going to be the formula? Yeah, so the correct answer should be C. Okay, is everyone all right with that answer? Yep. We're gonna end it here because from the next page we're gonna discuss the next thing. Okay, so any question you want to ask for today's lesson?